Now we're going to review 8.2 and 8.3. So this review video is going to be a little bit longer. So the first thing we see is we need to use this function to answer the following. And since we see that there are x's in the numerator and denominator, we know that it can have all of these things. And we also know that since we see that they have degrees of greater than 1, that we need to factor them first. So looking in the numerator, I can tell that I have a GCF of x. So if I factor that out, I have this, and also in the denominator I have a GCF of x. Okay, so then I think to myself, what is a, so this is 3 trinomials, so I need to use my AC method, or 3, this is a trinomial because it has 3 terms, sorry. So a is 1 and c is -8, so in my head I'm just going to think about what multiply to give me -8. Well, my options are 1 and -8, 2 and -4, or the opposites of that. I need to get a negative when I add them, so I know my larger number needs to be negative. And how can I get, there's no, I have a sign error. There we go. Never mind. To get -8, I now have, or to get +8, I know that I need the same sign, and since this is a -6, I know these are going to both need to be negative. So what are the ways I can multiply to get 8? 1 and 8, 2 and 4. Which ones of those give me 6? 2 and 4. And then I have my x. Now here, let me double check my signs, make sure, okay. Here I do have a negative, so I know I'm going to have 1 positive and 1 negative. I know my larger sign needs to be positive, so whatever my larger number is going to go here. So a is 1, c is -10, so I need to multiply to get -10, so that'll be -1 and 10, -2 and 5, that'll work. 5 and -2. Okay, so now as I look over here, I notice that I have the following factors, x and x, that can both cancel. Remember, once this is factored and you have a factor that cancels, you have to take that factor, set it equal to 0, and that is where a whole would be. So since that factor canceled, that makes a whole. Let's see if I have any other factors that cancel. Yes, I do. X minus 2 also. So I take x minus 2 and set it equal to 0, and that creates another whole. So remember, as we are graphing along, we would jump where that is and put an open circle there. Okay, so now my new function is x minus 4 divided by x plus 5. If I'm looking at that, when I need vertical asymptotes, remember that is where the denominator equals 0, so looking at my denominator and taking anything that has an x and setting it equal to 0, so my vertical asymptote is going to be x equals -5. Horizontal asymptotes, remember you compare the degrees, so looking at the degrees, my degree of my numerator is 3. My degree of my denominator is also 3. So when they are equal, my horizontal asymptote is that leading coefficient of the numerator, which is 1, divided by leading coefficient of the denominator, which is also 1. So 1 divided by 1, I have a horizontal asymptote at y equals 1. Zeros are also another name for x-intercepts, and we get these by where the numerator equals 0. So x minus 4 equals 0. So 4. Okay. Remember, you are going to have to study because you are going to need to know where to get those things from. Okay. Next, on this one, use the function to answer the following questions, then graph. As you look at this, you'll notice there's no x's in the numerator, and the x in the denominator just has a power of 1. So this is from 8.2. This is going to be a reciprocal function. So I know I'm going to have vertical and horizontal asymptotes, and my parent function looks something like that. So I need to probably first figure out what my transformations are. Okay, So if we look here, it should, my normal parent function is 1 over x. So anything that's not that is a transformation. So this 4 is a transformation. In the numerator like that, that means it is a stretch. So I have a vertical stretch of 4. In the denominator here, I have a minus 3. That shifts me, so it is a shift. If it's subtraction, then it moves to the right. If it were addition, it would move to the left. And then out here, this is a shift up and down. If it is positive, it moves up, which ours is. So now we need to talk about our vertical asymptote. Well, my vertical asymptote normally was at 0. If I move it up and down, look what happened. Oh, nothing. But if I move it right and left, does something happen to it? Yes. So vertical asymptotes are going to be x equals, and they always go with your right and left shift. So since I've gone to the right 3, it will be at positive 3. Here's my vertical asymptote. Sorry, that's kind of hard to see. Okay. And then my horizontal asymptote, so it normally was at y equals 0. If I move it up and down, it doesn't move, but if I move it right and left, it doesn't move, but if I move it up and down, you'll see that it does move. So it goes with any shifts up and down. So it will now be at y equals 2. So where those two asymptotes cross, that is called the black hole. So our black hole is at 3, 2, and we will use that to start all of our counting from. Okay, so let's go ahead and graph. Now my normal points are as over 1/2 up 2, over 1 up 1, and over 2 up 1/2. We also do left and down as well. But in this case, with a stretch of 4, all of these ups get multiplied by 4. Any stretch or compression multiplies your ups. So I'm going to go over 1/2 and up 2 times 4, which is 8. I'm going to go over 1 and up 4. And I'm going to go over, this is a 1/2, I'm sorry, over 2 and up 1/2 times 4, that's 2. Okay, so this is kind of going to be tricky to draw in there. Remember that you cannot touch or cross your asymptotes, but your graph should get closer to them without touching or crossing them. Okay, and I need to do the same thing to the left and down. So left 1/2, down 1, 2, 3, 4, 5, 6, 8, and left 1 and down 1, 2, 4, and left 2 and down 2. Again, get closer to your asymptotes, but do not touch or cross them. Okay, so now domain and range. Domain is your left to right, so as I travel from left to right, I've got graph here, here, here. I don't have graph there, so my domain is going to be all real, oops, that's not the color I wanted, all real numbers except the x value of my black hole. All real numbers except x equals 3, because that's the number of my black hole. Now my range is bottom to top, and it is going to be all real numbers except the y value of my black hole. Okay, so notice I did my black hole purple and blue, my shift purple and blue, vertical asymptote, and domain, and this are all the same. So be careful when you do that, because if you miss one of them, then you'll miss all 3. Okay, last but not least, x-intercepts. To get the x-intercepts, we sub 0 in for y. Okay, so we subtract 2 from each side. then we multiply by x minus 3. You have to distribute on that side. So negative 2x plus 6 equals, those will cancel, 4, subtract 6. I guess I didn't show my minus 2 in there. Negative 2x equals negative 2, so when I divide by negative 2, x equals 1. So my ordered pair here is going to be 1, 0. And yep, I do have that on my graph. I always like to double check. I probably should have done that before I graphed it. Okay, next one. Same thing, list the transformations. Okay, so in this one, my numerator is a 1, so that tells me I don't have a vertical shift, or sorry, a vertical stretch or compression. So, oh, but I do have a negative out here. So that's a reflection over the x-axis. Then down in the denominator, I have a plus 5. Remember that shifts us right and left. Since it's positive, it moves us left because it does the opposite of what we think it's going to do. So my black hole is going to be at negative 5 something. And let's see if we have any shifts up and down. Yep. This is an up and down. It's negative, so it's going to shift us down 1. So my black hole is going to be at negative 5, negative 1. There we go. Now vertical and horizontal asymptotes. Your vertical asymptote is always x equals, and it's going to be the same as your x value of your black hole, because the black hole shoots the force fields out up and down and right and left. And then your horizontal asymptote is the same as the y value of your black hole. That's your right and left. Then my domain and range. Domain is going to be all real numbers except that x value of my black hole. And my range is going to be all real numbers except the y value of my black hole. Okay. X-intercepts, put 0 in for y. And I'm going to go ahead and move this negative up with the 1 so that I know where it's at and I know I remember to take care of it. So add 1 to both sides. 1 equals negative 1 divided by x plus 5. You need to multiply both sides by x plus 5. Over here it will cancel. Here we'll distribute a 1, so that's not really going to change anything. So I've got x plus 5 equals negative 1. Subtract 5 from both sides. X equals negative 6. Remember, you have to write it as an ordered pair. Negative 6, 0. So negative 6, I'm going to go through that point. So remember, your normal points for this are right 1/2 up 2, right 1 up 1, right 2 up 1/2. However, since I've reflected these, that means all my ups are now going to change to downs. And normally I have left and down, but again, downs and ups are going to switch places. So I'm going to go right 1/2 and down 2, right 1, down 1, and right 2, down 1/2. So my branch will be below and to the right of my black hole instead of normally, which it goes above. And then over here, same thing. Normally we go to the left and down, but because of that reflection, we go to the left and up. Grab the next video for 8.3.